The University of Maryland ETE Scholars Program joined the university's Ecological Engineering Society to form a team of students who share a passion for designing and implementing different eco-technologies to solve environmental problems. The team entered this year's RainWorks competition with the goal of designing an innovative approach to stormwater management, something more sophisticated than the typical permeable pavement and rain garden approach. After contemplating different methods of stormwater mitigation, the team decided to implement an algal turf scrubber as a solution to campus runoff. An algal turf scrubber, abbreviated as ATS, is an ecologically engineered technology that removes nutrients from water through the cultivation of algae. As water flows through an algal turf scrubber, the algae photosynthesize and metabolize nutrients like nitrogen and phosphorus in the water. The process relies on nature to remove nutrients from water as opposed to the expensive and energy-intensive methods of mechanical and chemical nutrient removal. The goal of this project is to build an ATS that would offset nutrient pollution that runs off from the Terrapin Trail garage located on campus. There is a retention pond right below the garage that currently receives its runoff, but when a significant storm event occurs, the pond overflows into Paint Branch Creek, allowing nutrients and pollutants to become mobile. Our team plans to design a 2-section, 4-pass ATS, which will run down the slope adjacent to the retention pond. Water would circulate through the pond and the ATS. As algae grow on the ATS, nutrients are effectively taken out of the pond water. With a runway that is 1 meter wide and just over 60 meters long, an ATS of this scale would remove more than enough nutrients from the retention pond to make up for the garage's runoff. The only energy input for the algal turf scrubber is power for the water pump. The team plans to utilize a solar array located on top of the parking garage to power the ATS. This way the system will be powered by 100% renewable energy. While providing environmental benefits, the implementation of this ATS would also serve to educate and engage the public on campus. Students are constantly walking to and from the Terrapin Trail garage when leaving or coming to school. The site is also frequented by students and families who are coming to see the Maryland athletic events. We want to incorporate information panels and benches next to the ATS to educate those who are passing by about this unique technology and how it works. We want to turn this plot of land that currently has no use into a green space where anyone can study or just sit outside listening to the relaxing sound of water running and pulsing down the ATS. The project has been approved by University of Maryland facilities, which demonstrates its feasibility and benefits to campus. The implementation of this project would result in one of the first, if not the first, ATS ever constructed on a college campus.